whenever you
All
want to start,
right.
Charlie.
So this is our stats project called the Basketball Stats Project. The group members are Matthew Ilaregi, Matt Ingram, Riley Sanders, and Chris Toft. So for a brief overview of our project, our response variable that we were interested in analyzing was player efficiency, the same response variable in an example in class, and we wanted to give a little bit more an in-depth analysis, something that wasn't given in class. So to collect our data, we used ESPN's top 100 list, which was, as the name says, is a list of 100 players that ESPN predicted was going to do good in the 2018-2019 season. Once we got that list of 100 players, we used basketballreference.com, which is one of the largest basketball archiving sites on the internet, and we compiled about 42 different variables for those 100 players, about 20 which were used in our final model. So speaking of the final model, we, in the end, placed a log transformation on our Y, on our on our response variable player efficiency, because although equal variance and linearity did very well throughout our entire project, normality was a little bit off, as seen in the QQ plots. So we thought that a transformation on PER would be the best fit. In the end, it was, as will be seen in the residual plots. So in our final model, our predictors were BPM, which is box plus or minus, which basically tells how well a team does with a player on compared to off the court. And it takes into account the offensive plus or minus and defensive plus or minus. Next, with position, that's pretty straightforward. The positions were center, shooting guard, point guard, power forward, and small forward. Then we used field goal percentage, which was just the total percentage of shots made over shots taken, and then usage percentage, which was just how much they were used in a game, and rebounds per game, or RPG. So after doing a model utility test, which was testing the coefficient of every single one of these explanatory variables, we got an F-score of 137 and a p-value of functionally 0, which means that our final model was incredibly significant, and that was good news. Yeah.
Alrighty. So next, we wanted to take a closer look at our categorical variable position. So in order to do this and to test if it's statistically significant when predicting player efficiency, we took a partial F test, including position in the full model, but not in the reduced model. So after taking this test, we found that center, small forward, and power forward were significant predictors, but not point guard or shooting guard. However, with a F value of 2.3 and a P value of 0.06, these results were a bit unclear. So we next wanted to take a closer look at an interaction plot to further test these categorical variables.
Here we have an interaction plot between usage percentage and the log of player efficiency. We decided to take a partial F test to get a better look at the significance of the interaction between usage and positions. As you can see, we got an F value of 1.4 and a P value of 0.223. So we conclude that we do not have significant evidence to say that the interaction between usage and position is a significant predictor. We also decided to look at the slope coefficients of the usage percentage interacting with position, but based off of center. So if you go down the left column there, power forwards are 0.018963 higher than centers. Point guards are 0.016557 higher than centers. Small forwards are 0.0211 higher than centers, and shooting guards are 0.0122 higher than centers.
All right, so what does this mean in regards to basketball more broadly as it relates to usage percentage and position? So our data shows that for each increase in usage percentage, it results in a higher increase in the player efficiency rating for all positions other than center. Now, usage percentage is a measure of how much they touch the ball, so it shows that centers do not need to touch the ball as much as other positions in order to stay efficient. Now, this makes sense as the NBA has been moving towards a more spread out style of play, shooting more threes. So they like to spread the floor and only keep the center in to pretty much play defense and rebound the ball. Now, the interaction plot, as seen, is not that significant. So it shows that the slopes for each of these positions are actually not all that different for our sample. Now, given that we've only took a sample of the 100 best players as predicted by ESPN and not the whole league, this could be very different when we take into account the 500 plus players. But for the best players in the league, there really was no difference. And that's our presentation.